See here we have N channel 3-leg MOSFET. Okay, I actually see this one is drain, here is the source. See, this side is the source, drain and gate. Actually drain I opened here. Okay, see here it's open because I wanted to show you in case of gate voltage. Actually here is the voltage divider, gate voltage is there, but the concept is in 3-leg MOSFET, if voltage will comes, it will be in on condition. That is true or false. Practically I will show you. Actually here is the voltage divider. See, here is the voltage divider. The main source will come here and the voltage divider voltage will go to gate voltage. Here is the source. Now the source will be the forward bias in N channel, right? Source to drain will be the forward bias. Means easily the voltage will pass. In case of 19.5, it goes here and it will become around 19 or something. Some voltage drop will happen because it's a forward bias. In case gate, if it is on condition, complete voltage has to come to this side. Okay, this is drain side. Drain is open, but here is the 25 volts. It's a AC drive. Actually I kept it open. I will show in both condition. In case it's a drain open and in case of source open, both the condition, the gate voltage, if it is a 4.5 volts, then what will be the result? Okay, now I will turn it on and I will show you now the source, drain and gate, what will be the voltage. Now the condition is gate, drain is open, gate will be 4.5 volts and here is the 20 volts. Okay, so now I am going to on it. See, turning on. Now supply entered. Okay, now first the gate I am going to check. See, the gate voltage 3.9 or 4, whatever it may be, but here it's a drain is open. Drain is just a touch 19.1 is the drain. Okay, and what about source? Source is 19.4. okay, here source is the 19.4 and drain is 19.1, but gate is, see, 3.7 or 3.8, whatever it may be. So the divided voltage will come to there, 3.7. Here is the source. Okay, here is the voltage divider. Now you come to know, right, this will be in off condition. The gate has 3.9 or 4 voltage, then also it is in off condition. Why? Because N MOSFET always need more than the source voltage. Okay, anyway, now vice versa I will do. Now it's a drain, I will connect to this motherboard. See, the drain on the motherboard is 25 volts. This one won't pass there. Means here, even though voltage is there in gate, it will be less, then it will be in off condition. That I wanted to show you. Now I will connect the drain. Okay, then what will be the result, that I will show you. See, now what I did, I opened the source. Okay, now gate has 4.5 and source, drain has 25 volts, and what will be the source? In case gate has some voltage, and what will be the source? That is the main concept you need to understand here. Okay, I am turning on. Okay, see here, I am turning on. You can check the multimeter and what voltage you will get. Okay, just I will show you the drain, source and the gate. Okay, check the multimeter. Now what is that? 25 volts is drain. Okay, now here is the 4.5 is the gate. 4.5 is the gate and the source. Slowly I am touching, please check. 6.8. 6.8. See, just a minute. 7 or 6.8 something it's coming. Okay, see, actually the source on the motherboard is 19 volts, but here is the source on the 3-leg MOSFET is 7. So what you call now? This is the concept here. Okay, see, here is the gate. I remove this. See, here is the gate has 4.5 volts, drain has 25 volts, and some of the amount, if you have some voltage, some of the amount voltage will pass here.